The Grand Canyon documents how much change has occurred in western North America. Western North America certainly did not look the way it currently does in North America's early days. In fact, North America was once a much smaller continent. About 1.8 billion years ago, the area of the Southwest, which includes the Grand Canyon, was being added to North America. It was the bottom of the seafloor, but as volcanic islands, or perhaps a microcontinent, fused with North America from the west. The plate of these islands or microcontinent subducted under the North American plate, which then created denser material, which sank, and lighter material, which rose. And this helped to uplift the area. And as this process continued, some of this lighter material would form the lighter granite, which is visible in the darker metamorphic rocks. During the time period of about 1.2 billion years ago to 800 million years ago, there was additional subduction of material under the western North American region. There was uplift and erosion, which created a complex mix of new igneous and sedimentary rock. Western North America expanded from its former border in the Wyoming-Colorado region to just south of the U.S.-Mexican border. There were no animals alive at this time, and certainly there was no life on land. The only fossils known from the Grand Canyon during this time period are of cyanobacteria, which are the blue-green algae, a photosynthetic type of bacteria, and the large mounds of bacteria known as stromatolites. An unconformity exists, sometimes called the Great Unconformity, where no new rock strata were laid down from the period of about 800 million years ago to around 525 million years ago. So the next layers in the Grand Canyon are dated from the Cambrian period. Apparently just prior to this, the conditions were not depositional. They were not conducive to the laying down of new rock layers, or else if they were laid down, they were subsequently eroded. During the Cambrian, different environments existed in this area. At first, it was an environment along the ocean shore, and then it was to some degree offshore as a marine environment. And then by 505 million years ago, it was further offshore. And there are fossils of the marine invertebrates known from the Cambrian period, which have been found in the Grand Canyon, such as trilobites and brachiopods. These images here are not from the Grand Canyon. These are just sample trilobites and brachiopods. There is a layer which was laid down during the Devonian period, although it varies in thickness in different parts of the Grand Canyon from about 100 feet to 450 feet. Earth underwent a great deal of change during the Carboniferous period. The continents were fusing to form the supercontinent Pangaea. The late Paleozoic Ice Age was approaching, and certainly the rock layers of the Grand Canyon depict change because this area was near a coast, but while some layers were laid down in marine environments and depict marine life, such as brachiopods, the armored squid known as cephalopods, other areas were laid down along rivers and as part of a coastal plain in terrestrial environments and have plant fossils. And so the relationship between the land and the sea was changing. And so this coastal area was sometimes marine and sometimes terrestrial. The uppermost layers of the Grand Canyon were formed during the Permian period. This was the final period of the Paleozoic era. At the end of the Permian, there was the worst extinction of life which is known during the past 500 million years. During these Permian times, the area of the Grand Canyon was sometimes marine, sometimes terrestrial. In fact, some of the light-colored sandstone where the rocks have fractures at diverse angles were deposited when this area was a series of sand dunes for about a period of 5 to 10 million years in a more desert environment. While there are areas of the Southwest with significant deposits formed during the Mesozoic era, there are only a few areas of the Grand Canyon where Mesozoic rocks are overtop those of the Permian. So most of these rocks have eroded and are no longer visible.